Ideas in STEM Ed is a production of the Idea Engineering Student Center at UC San Diego, which works to promote community, success, and inclusion at all levels. My name is Darren Lapomi, Professor of Nanoengineering and Chemical Engineering and Faculty Director of the Idea Center. The purpose of this podcast is to provide a forum for the discussion of innovative and inclusive approaches to teaching and mentoring, and to support the personal and academic flourishing and success of students in science and engineering. To learn more about the Idea Center, visit jacobschool.ucsd.edu/idea. My guest today is Irene Reizman. Irene is an associate professor of chemical engineering at the Rose-Hulman Institute of Technology in Terre Haute, Indiana. Irene obtained her bachelor's degree in engineering at the University of Michigan in 2008 and her PhD in chemical engineering at MIT in 2015. She has industrial experience with a number of companies, including LS9, Whirlpool, and Schott AG. Her research interests include biochemical engineering, including metabolic engineering of microorganisms for renewable chemical production. Her teaching interests largely parallel this focus, with additional interests in chemical process and product design and biotechnology. Dr. Reizman has many honors and awards, including the German Ministry of Research and Education Green Talents Award earlier in her career, and was recently named the Alfred R. Schmidt Endowed Chair for Teaching Excellence. Irene, welcome to the podcast.
Thanks for having me.
What led you to study chemical engineering?
Well, as a high school student, I was interested in chemistry and biology and also in agriculture. My parents have a farm in Western Ohio, and I grew up on a farm, and I saw kind of the revolution in biotech and agriculture, and I thought that was really interesting. I mean, as I was growing up, we started planting things like Roundup Ready soybeans, which were a big innovation at the time. So I saw this going on, and I thought I wanted to be involved in some industry that was adjacent to agriculture, but I also, wasn't sure that I wanted to go on and go all the way through school to get a PhD or professional degree. So I also wanted to find a program where I could graduate in 4 years and get a job if I wanted to, and engineering appealed from that sense. And I saw some advertisements, for what chemical engineers do, and so after visiting some different schools and going to their engineering field days or their engineering camps, I just thought chemie would be the best choice where I could combine my interests in chemistry and biology and agriculture and kind of apply it to practical problems.
That's great. I think most high schoolers probably hear chemical engineering, and if they think about it at all, they're thinking that it is something to do with chemistry and maybe making shampoo or something.
Well, I think I still had that impression in high school too, because I was like, well, I could make consumer products or I could work on food. And I mean, it's true that you can definitely do all those things, but there's, I guess, a lot of other aspects to it as well.
But the industrial biotechnology aspect is something that I think came to you relatively early in your studies.
Yeah, well, I was interested in it early on, but as you've experienced, the chemical engineering curriculum has a lot of required courses. There's not always that much time for electives as an undergrad, and so I took some electives in biochemistry and food science, but ultimately my work experience was a little bit more on the materials side. So I interned at Schott, which is a German company that does a lot of glass production. I worked on producing glass ceramic cooktops, and so then when I was looking for jobs
was that in Germany? Sorry.
Yeah, that was in Germany. It was a great internship. Mm-hmm. I actually was at their headquarters in Mainz, Germany. But yeah, then when it came to looking for a job, after graduation, I had interest in the bio side, but I didn't necessarily have that much experience. And I ended up, talking to companies that worked in materials and consumer products a lot. And that was then how I ended up working at Whirlpool, because they had a very cool leadership development program. I was interested in learning more about the consumer products business. And so I had some experience with materials for for appliances through my work with like the glass ceramics and glass ceramic cooktops. So then I ended up working for 2 years at Whirlpool, rotating to different locations within the company. And I worked in like material selection and design for home appliances.
Mm-hmm.
And then, yeah, after 2 years of working in industry, I decided actually I did want to go back to grad school.
Did you have thoughts of did you have thoughts of that as you were an undergraduate, that you would work for a while to see what a chemical engineer actually does in the real world and then go back, or were you thinking that you might stay in industry?
I wanted to work and see what I could do with the chemical engineering degree. And I wasn't sure if I wanted to go back to grad school. I thought maybe actually I would get an MBA or something like that and work more in kind of project management. But after spending a couple years in industry, I missed kind of the being able to do more of the technical side of it and like work with really new technologies, because we definitely did some interesting things in appliance design, but you're constrained definitely by cost, and then also just kind of what else is on the market, what consumers are looking for. So I was like, well, maybe I can go back to grad school and get into an area that's a little bit more technology driven.
So I am seeing a theme. You grew up in Western Ohio. You went to undergraduate in Michigan. There was a where was Whirlpool located?
In Michigan,
In
Western
Michigan,
Michigan.
and now you're in Indiana. So definitely a tie to the Midwest.
Mm-hmm.
And then you went to MIT for grad school. And what did you study there, and how did you choose your lab?
Yeah, I studied chemical engineering at MIT as well. When I applied to grad school, I applied mainly to chemical engineering programs because I knew, I guess I knew that the coursework I did in my bachelor's was transferable, and I still felt like I had a lot of options as to what I could do in grad school in chemical engineering. I was definitely interested in integrating more of a bio component. I thought at the time maybe more biomaterials. And obviously MIT has a very broad faculty. They have faculty who are doing kind of all the aspects of chemical engineering. So during my grad school visit, I enjoyed Boston, and it was neat to see the diversity of things going on at MIT, and I just decided I would go ahead and go for it and try out somewhere different for grad school. Go outside the Midwest, and I think that was a really good choice.
During your PhD studies, is that when you became interested in teaching careers, or were you mostly research focused during that time?
Yeah. So going into the PhD program, I definitely wanted to explore my interest in teaching. I realized that the PhD program is mainly research based, so definitely research would kind of have to be the centerpiece of anything that I did. But I definitely did want to explore teaching, and that was something I expressed to my advisor too. That I wanted to be a TA on a core course. So when I TA'd during my graduate studies at MIT, I TA'd for their integrated chemical engineering course, which is their senior design course. And they do shorter modules. So I TA'd for 2 of those modules, which added up to like roughly a semester worth of TA. So I didn't have tons of TA experience in grad school because research was kind of the focus, and I was being paid on a
Right.
research grant and everything. But there were other ways to supplement it outside the classroom. MIT has kind of a neat summer program that's run by students called the Educational Studies Program. And, it's mainly actually run by the undergrads, and they invite high school students to come to campus, and different groups of students develop courses for the high schoolers to take. They're, undergrads developing courses, grad students, postdocs, basically, anyone in the community. So with one of the other students from my graduate lab, we developed a course for high school students on metabolic engineering that we gave over the course of, I think it was about like 6 sessions, and they would meet like once a week for 6 weeks, and the high school students would come in and we do activities with them. Some of it was like hands-on, like we talked about enzymes, and we did an experiment where we, added meat tenderizer to Jello to show the impact of the proteases and things like that.
Did you find that your mentors, particularly your PhD supervisor and your committee members, were receptive to careers in teaching? You know that MIT is a very intense research environment, and sometimes there can be some friction. Did you find that, or no?
So my advisor, I think, was receptive to a variety of career paths. She had students go in a variety of different directions. So, she was certainly receptive to writing me recommendations that were based on teaching. And she also taught kind of core undergraduate courses like the material and energy balance course. So, she enjoyed that aspect of the job too. And then, I didn't really get any specific pushback from committee members if I asked for recommendations, but I think, they all kind of view it as ultimately, it's up, they want their graduates to be happy in the jobs that they're doing. And even if it's not research per se, they want to see them going out and being successful.
So Rose-Hulman is a primarily undergraduate institution that focuses in science and engineering. Is that a fair statement?
Yes.
And there aren't that many schools that fit that categorization. So when you're applying as someone who has a passion for teaching, but in engineering, how did you find those positions? Were you worried that, there aren't that many tenure track openings in this area? Were you tempted to apply for like chemistry departments in other places? How did that work?
So my particular strategy for it was that I would apply for the position at Rose-Hulman, but I would also look at possible postdoctoral positions, because if you have a passion for teaching, you can still follow that along with research too. So I thought, well, I'll give it a shot to apply to Rose-Hulman, because there is a limited pool of these types of positions. I kind of looked at alternatives as far as finding a postdoc and then kind of continuing in that direction, and then maybe trying to to go into maybe a more, I guess, traditional route of academia where you would have a research group and teaching. But the position at Rose-Hulman worked out, so so I ended up going that direction. But I've talked with other students who are kind of looking at teaching, or other graduate students who are looking at options in teaching, and another strategy in the job search could be also to look for lecturer positions or teaching faculty positions at larger universities too. And there are a good number of those advertised each cycle, although again the pool is kind of limited. But
especially in the UC system.
And as far as like other departments, like chemistry departments, personally, that my expertise, I think, wouldn't overlap enough with a typical chemistry department at a primarily undergraduate institution for me to land in a chemistry department. Probably if I were to look for something that were not chemical engineering, I would have to look more in kind of general engineering departments, which also exist as well.
So tell me about your current department. How many faculty are there, and how many courses do you teach? What courses do you teach?
Yeah, let's see. I'm not sure if I'm going to get the exact number right, but I think we're a department of 11 faculty, and then we're on the quarter system at Rose-Hulman. In each quarter, I would teach 2 to 3 classes. So for example, if I were teaching 2 classes, it might be 2 sections of one class and 1 section of another, or 2 sections of one class and then a lab, and then if I'm teaching like 3 different classes, it might be that I'm doing a lab and like 2 electives, or some kind of smaller class where it's a little bit easier to manage the number of different things that I'm teaching at one time.
Do you have MS students as well, or solely undergraduates?
We do have MS students as well. So we have like a course of classes that we offer for our master's students. Right now, our master's program is fairly small. We only have a few students each year, maybe like 3 students a year or something like that. So the focus is really on the undergraduate program. And then we'll have some of our undergraduates take like the master's level courses as electives too. So that's kind of what keeps them fully enrolled.
Yeah, and it keeps the numbers in your classes large enough so that the registrar doesn't cancel your section.
Yeah, although like for some of the things like the master's level classes, if we do have master's students, we guarantee that they would be offered. So, it's not going to be canceled even if it's actually only like 2 students for those. So
That's like
sometimes
my
students
dream.
get a very individualized experience.
Yeah, that sounds like a lot of fun to have. You could almost have class in your office on the whiteboard, and it's like office hours but structured. That sounds great.
Yeah, I've taught, I guess the smallest class sizes that I've taught are like right around, I think, three or 4 students, and then maximally I would teach a class size of about 30 students. So I think that's nice. I get to know all the students in my classes, and that's one of the things I learned starting at Rose-Hulman is students expect you to know their name, to know something about them. So it is worth the time to make the effort in the first few classes to learn who all your students are. Like, we have the little sheets we can print out with all the student pictures. So I kind of do a little exercise where I'm finding all the students, making sure I can associate the names and the faces. So I've tried to pick up some tricks for learning people's names and things, so that we do have that more individualized experience.
Yeah, in terms of social psychology and teaching and learning, knowing names is so important. When you hear your name, it's like what did Dale Carnegie say? The sweetest sound. So another area of interest is undergraduate research and how it can complement classroom teaching. And I know that with your new endowed chair, congratulations on that.
Thank you.
You've spearheaded a major initiative to get more students involved in research, to recruit more faculty to accepting students. How is that effort going, and how do students get involved in research typically?
Yeah, so my effort in the endowed chair area is really just getting started, and so I don't have a whole lot to report in that area yet, but I have been working with another group through the Kern Entrepreneurial Engineering Network to also work on similar goals of involving more students in research and getting them started. And I think we've had some good success as far as getting materials together. We're starting to record videos that we can distribute out to different universities, that can be utilized in classes or outside of classes as part of workshops to help students be introduced to what is engineering research, why should they get involved, and then also develop some of the skills that they could use as researchers, things like kind of defining their project question, finding resources, developing resiliency in research, and all of those areas. Because we were finding, both at Rose-Hulman and with the other members of the working group, is a lot of times students get involved in research just because they're they approach a faculty member after class and say, do you have a project, or can I get started in your lab? And that's a great way for them to start with research. And it's really awesome when that happens, but not every student is going to feel comfortable with that, especially if they're coming from kind of a background where they're less familiar with like kind of the structure of higher education. They may not even realize that that's an option for them to be involved in a faculty lab. They kind of see that as like a separate structure away from the undergraduate classes. So I think, we want to get the message out there that it's really available to everyone. And you don't necessarily have to even know, like, you don't have to march up to a professor and say, I want to work on your project. That, if you give some interests, there are people available who can help pair you with faculty members who have projects.
Yeah, it can actually be the source of significant inequity. There's the academic culture, the big part of the iceberg below the surface, that you really only know if someone has been there to tell you about it. And it just seems like it's out of reach. It exists in a different dimension. And also among students who do know about research, it's a scattershot approach. They knock on X number of doors or send X number of emails, and maybe one faculty member will give them the time of day, and then by complete luck they end up with a position. And it's great that what you're doing is taking some of the randomness and also the what is the noun that is arcane, the arcanity out of the process.
Yeah, because even as an undergrad, I guess I was aware that people did undergraduate research, but I wouldn't have thought, oh, I'm going to go up to a faculty member and ask about doing this. So I only got involved after, I got invited to be part of a program where they were trying to recruit more female students to pursue graduate degrees in engineering. So there was a little bit of funding for the undergraduate research project. So it wasn't just, me doing it for credit or volunteering in the lab, but I could actually get funded for it. And then there was a little bit more motivation to go after a position there.
Yeah. So in terms of physical infrastructure that you use for undergraduate research, do you have common shared facilities? Does every faculty member have devoted space? How does that work?
Yeah, at Rose-Hulman, we mainly have shared facilities. We have a few labs that are kind of designated as special projects labs. And then I have like a kind of a specific niche that I've carved out in the special project lab where my equipment lives. But we also do a lot of sharing between departments. And that's something I've enjoyed at Rose-Hulman, is that, in general, people are pretty friendly and happy to kind of help you get started and find space. They're not, highly protective of every space. So I've been able to work with faculty members in biology and biomedical engineering to use equipment over there, or use equipment in chemistry. And everyone's understanding that, we're working with undergrads and they're learning things, and, they need some level of direction and supervision with equipment too. So, it's like, I can work with maybe the technician in chemistry to find a time that he's available, and he can help train me and my student on using the GC over there, something like that, making sure that we're also getting some training for the instruments and not kind of turning the students loose on them without some background.
Speaking of collaborating and associations with other majors on campus, I noticed that your department has a minor in chemical engineering. What types of students do a minor in chemical engineering? What are their majors?
We don't get a whole lot of takers on the minor in chemical engineering. I think most recently, I know a student who went that direction because he started as a chemical engineer, but decided his passion was really biochemistry, and he switched majors to biochemistry, but he still kind of wanted to do something with the chemical engineering courses he took. So he earned the minor in chemical engineering. But yeah, we haven't had a whole lot of mechanical engineers or anyone else take us up on that. We do have students in civil engineering who do an environmental engineering focus, and so then they will come in and take chemical engineering classes to earn the environmental engineering minor.
Got it. That's a nice logical pairing,
Mm-hmm.
chemical and environmental. And yeah, how you mentioned that you have had classes stay on the books for as few as 2 master's students. What's sort of the average class size for your heat and mass transport class, your core classes?
Our core classes. Yeah, it fluctuates up and down. And this is sort of one of the challenges of working at a primarily undergraduate institution is that the institution is undergraduate tuition driven. So, funding for everything, basically everything on campus is going to be driven by our enrollment and how many undergraduates we have. And our incoming class sizes, I think, typically range in like 550 to 600 range. And you think, 50 students this way or that way, it's not that many, maybe, but that actually is quite a lot for us, like being over by 50 or under by 50 on the enrollment can kind of make a big difference. And so in chemical engineering, like our class sizes year to year, we've been as high as like 85 people in a graduating class, but then sometimes we're down around like 50 people in a graduating class. So then that'll make a big difference in our section sizes. I think right now in a typical heat mass transfer section, we might have around 20 students, but then sometimes it creeps up to like 30 students or it goes down a little bit. And then also, for example, I'm on sabbatical this quarter, and frequently we have someone out of the department who's on sabbatical or different things, and then we have to start reshuffling section sizes for that. But we generally try to not go over 30 people.
I should tell the audience that Irene and I are maybe about a mile away from each other right now, but because Zoom is so convenient, we're on Zoom. In your classes of 20 to 30, what classroom methodologies do you use?
Yeah. So we definitely try to incorporate active learning. And when we have these small class sizes, it can be it works especially well for some of the small group exercises. So, along the lines of things like think, pair, share, but then we can also kind of expand that into posing a problem, having a small group work on it, have them report out, and then kind of have a little bit of discussion in class. So, some of the classes are kind of I would say it's still lecture style, but broken up with these like active learning activities. I've actually tried out like a flipped classroom before for our kinetics and reaction engineering course, where then we primarily did problems in class and they watched the videos outside of class. I think that still needs tweaked a little bit, because I will say it was partially based on the fact that I had to make so many videos when we were teaching remotely for COVID. So some of the videos still need to be updated, but that one's kind of a work in progress, I would say. And then
how did you do the videos? Were they like Khan Academy style or pointing a camera at the whiteboard? How did you do it?
Yeah, so I mainly use my tablet for that. So it's kind of kind of a screencasting style for the most part, and that was just like out of necessity. I don't have a home studio where I could necessarily appear in the videos, but I wanted them to be a little bit more interactive than just me narrating PowerPoint slides. So screencasting was kind of the solution that I came up with there. But as I go through and edit videos and things, I'd like to kind of make them a little bit more engaging. I tried to break them up, into portions that you could watch as a screencast, like 10 minutes at a time, so you're not just watching like 50 minutes of me writing, but I think it can still be refined a little bit there.
In your typical, I guess, what might be your favored setup where you're doing some traditional lecturing and some active learning? What's the breakdown, and what do you have the students come to class prepared with?
Yeah. And I mean, it really depends. It depends on the class a lot. I don't have a great breakdown number in my head, because I would say it varies day to day. Some days maybe it's like, oh, it's 80% kind of traditional lecture material, like 20% active learning. But then some days it's like, okay, well, we're going to do spend most of our time on an example problem today, and then we do like the whole class session kind of back and forth with the example problem. So I'd have to work hard to figure out. I'd have to go back to my syllabus to figure out what the overall percentage breakdown is.
What aspect of pandemic era teaching do you think you'll carry forward into the foreseeable future?
I will continue to use tools like Zoom and Teams for meeting with students. Like that, I think students have become a lot more comfortable with those tools, and then that gives me some flexibility because, traditionally I would have office hours, and for office hours you have to kind of sit in your office and be there, and then I might be there for block off this 1 hour block, and then I actually only have like one student stop by or something. Or other times, I block off an hour and it's like back to back to back, and it wasn't enough time for all the students. And I think tools like Teams give me some flexibility to say, hey, I'm not in my office, but you can contact me over this tool, or we can make an appointment, and then we can chat and we can go over things. And there are nice like whiteboard tools on Teams, and a lot of people have tablets now, so it's not even that that much of a obstacle not to have your whiteboard or something from your office.
It's amazing how some students, when they're in the position where they're the only student in office hours, they'll ask their 2 or 3 questions and then they'll pack up and leave. And then there are other students who will ask their 2 or 3 questions and then ask you about everything else under the sun for the next 45 minutes.
Yeah.
And it's interesting. I can see how using remote meeting platforms do help organize that time.
Yeah, and it's nice for the students too, because then if they are like, and they have to go to their sports practice or this or that, they're all the way over at the gym, they can just like sit at a table and call me. They don't have to run back and run back again. But that said, the real in-person interaction is important too. I think we lose a lot of kind of getting to know the students if we don't have some in-person time as well. So I wouldn't want to replace everything with that, but certainly I think it's a nice tool to have in the toolbox that students are comfortable with using these kinds of remote tools too.
In your typical classroom, what strategies do you use to encourage open dialogue and inclusion and hearing from multiple participants?
Yeah, I feel like that's something I still want to work on, because I notice that, in small classes, you think, well, maybe people feel comfortable speaking up because there's, it's not a big class. They're not speaking up before a lecture hall of 300. But I definitely, see that some students are still kind of holding back. They don't feel, as confident. And then you kind of get into the rut where you have the same students speaking over and over again in class. One thing I do is I try to do some of the group activities or the pair activities. And then I've I've done different things, to kind of get students to mix it up in groups a little bit. Occasionally I'll assign groups or I'll let them group with their friends. And then I'll ask somebody to speak for the group. And then sometimes with these things where there's a group, I'll just assign somebody to speak for the group, because at least then they feel like, they're not expressing their personal opinion, they're speaking for their group, so they sort of have that to back them up, even if they're a little bit more uncomfortable speaking in class normally. But I think it's a challenge, and it's something I'd like to work on going forward.
Along with that, what are your other long-term goals in chemical engineering education?
Yeah, that's a good question. I guess in the next 3 years, as I work on my endowed chair project, I'd like to see more of our students able to engage with undergraduate research, or at least get some exposure and know a little bit more about what that means, and how they can utilize those tools for either graduate school experiences or for industry experiences. And I am very interested in process design and project design. So I would also really love to see students incorporating more real world context in their design. We've worked to kind of find some more industry partners for design projects and things. But that's kind of always an ongoing project with us. And I'd also like just to think about ways to have students understand the more of the global and social context of their design too. So that's something that's come up since the revision of the ABET student outcomes is for design. They want to look at, not just the global or cultural context as a constraint, but understanding the impact of the design on all of these things, the environment, economic impact, social impact, things like that. And I think that's an area where we can improve in chemical engineering, because we're very good at saying, separate these three components in a distillation column, but we're not always good at saying why do we even want the end product? Like, what are we going to do with it? What impact does that have?
Yeah.
Why did we even choose this processing route?
What's the underlying value system for making the choices that you do?
Yeah.
One final question. What are some tips with regard to learning and studying that you want to convey to students who might be listening?
Yeah. I think the transition from high school to undergraduate is difficult, and I think students need to give themselves credit that that it will take some time. And if you feel like you're getting frustrated, or things aren't going well, also cut yourself a little bit of slack, because it's going to take you some time to learn about new methods of learning. And so, resources like your university's learning center or peer mentors can be really great, because they can give you some directions on the kinds of study strategies that will help you be more successful in college level courses that maybe require a little bit higher level of analysis or different levels of thinking than you might be used to from the high school.
Wonderful. Anything else that you wish I had asked, or that you want to leave our audience with?
Yeah, I just would say, for undergraduates also who are considering grad school, I sometimes get questions from undergraduates like, you know, should I go to grad school? I'm really interested in teaching. And I would say it's definitely a part of the graduate school experience, but I also give a word of caution. Like, you might think broadly about what you want your focus in grad school to be, because most people who go to graduate school in chemical engineering will end up doing chemical engineering research. And there are actually new graduate programs popping up across the country, specifically in engineering education. So if you really know that that's your passion, you also might want to look at that direction, because I think the traditional chemical engineering program is great for learning about research, and there are certainly outside things you can do to learn more about teaching. But if you specifically want a teaching focus, there are some graduate programs now available that have that.
That is a great note to end on. Thank you so much, Irene. Look forward to hearing more about the outcomes of your endowed chair project.
Thank you.
Thanks for listening to Ideas in STEM Ed, a production of the Idea Engineering Student Center in the Jacobs School of Engineering at UC San Diego. This episode was edited and engineered by Sky Lee, with theme music written and performed by John Viviani. Title art was created by Caitlin Wong. Special thanks to Sarah Eckert for guest booking and marketing. The Idea Center works to promote community, success, and inclusion at all levels. To reach us for guest suggestions and other feedback, please send an email to ideadirector@eng.ucsd.edu. And to learn more about our programs, visit jacobschool.ucsd.edu/idea. As a final note, the views expressed by me or the guests do not necessarily reflect those of the Idea Center, the Jacobs School of Engineering, or UC San Diego. See you next time.